Today's tutorial, I want to talk on isomerism and isomers of alkanes. When we talk about isomerism, we are talking about compound with the same molecular formula but different structural formula. Okay, so we can have two compounds with the same number of carbons, the same number of hydrogen when you count them, but their structure is different. Therefore, they have different names. So, let's start by trying butane. You know butane is an alkane with 4 carbons. So, in my first tutorial, I didn't say something about how we name the alkanes. For you to give the name to the alkane, all that you need to know is that you consider the carbon of the longest chain. So the carbon, if the carbon is 5 carbons, we name it pentane. When the carbons are 4, we name it butane. When the carbons are 3, we call it propane. So we consider the carbon of the longest chain, then we give the name to the alkane. So let's try and then write the structure formula for butane. We know that its molecular formula we've written in the first tutorial. So let's try and then let's write the molecular formula. With the molecular formula, let's try always use the formula. Always use the formula for you to get the molecular formula always correct. So here, talking about butane, butane means the carbon is 4. So we just substitute, change this one to 4, and then your hydrogen, and the end here is also 4. So 4 times 2 will give you 8, and then 8 plus this one 2 will give you 10. So this is how the butane molecular formula is written. So let's try and then write the structure formula for butane. The structure formula means that we want to distribute all the hydrogens around the carbons and see what will happen. So now we have butane, 4 carbons. So we try to bond the carbons together, and then because the carbon is having 4 outermost electrons, we try to add the hydrogen to the other part. So here you have hydrogen here, hydrogen here, hydrogen here, and there's a carbon-carbon single bond here to complete, because the carbon is saturated, to complete all, or to use all its outermost electrons in bonding. So when it comes to this place too, here, one of the electrons will be used here, the other will be used. So here, 2 electrons are being used. It will be 2 electrons that can be bonded by the hydrogen. Here to the same thing here, and here let me 3. So 1 here, and then 1 here. So count the number of hydrogens. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They are the same here. How many carbon? 1, 2, 3, 4. They are also the same here. So this is we call butane in a structure form. But this same butane, we can write it different way by changing the arrangement of the carbons. We can say carbon, 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 3 carbons, and then the 4th carbon, let's try and then link it to the 2nd carbon. And then let's try and then distribute the hydrogens around the carbons. So have 1 hydrogen here, another hydrogen there, like this. So have hydrogen, 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 hydrogen here. So with this, for you to know that you are right, count the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The same as the number of hydrogen here. How many carbon? 1, 2, 3, 4. The same carbon. But check the 2. Do they all have the same structure? It's no. You can see that the structure of butane is different from this structure. So we can't call this alkane a butane. Again, the name has changed. So to name this alkane, we consider the carbons on which this branch is connected to, counting from left to right or from right to left, the nearest carbon. So counting from right, 1, 2 is on the second carbon, counting from the left, 1, 2 on the second carbon. So to name this compound, because this compound is on the second carbon, we say that 2 and we bring hyphen, and the name of this compound, to write it, is CH3. So the name of this compound is called methyl. It's called methyl. So now, for you to be able to name the compound, you need to know the name of this compound and then know the name of this alkane too. So the 2-methyl. And then now you count the carbons of the longest chain. 1, 2, 3. That's the carbon of the longest chain. Okay, you also count 1, 2, 3. Also count from the right to left. 1, 2, 3. Or when you count the longest chain, you count 3. And therefore you have the name propane. 2-methyl-propane. And then butane. You have the same molecular formula, but the structure formula is different. That's what we call isomerism. So this compound, butane, is an isomer, and then 2-methylpropane is also an isomer. Okay, so let's take another example. Let's take pentane. And you know that pentane is having 5 carbons. So let's try to just distribute hydrogens around them. The simple form is not difficult. Just try and then bring the hydrogen around them. So hydrogen, 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 and then hydrogen. So let's see the formula for CnH2n plus 2. So pentane means 5 carbons. Let's substitute the 5 here. 5 times 2 is what? 10, plus this one give us 12. So need the hydrogen should be 12. Let's count the Z. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It means that's correct. So this is what we call pentane. Alright? So let's try to see something. Let's try and then change this carbon and bring it to this particular area and see what will happen. So let's point to say II. 1, 2, 3, 4. Let's just use 4 carbons and try to connect 1 carbon to this particular point and try to just distribute our hydrogens around the others. So I have hydrogen here, hydrogen also here, hydrogen here, hydrogen here. Okay, so let's count our hydrogens and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we the hydrogens are 12. Let's count the carbons. 1, 2, 3, 4, 5 is correct. But the structure is different. So how do we name this compound? I said that we consider the carbons of the shortest possible chain, or the counting the number of carbon which is very close to the compound, the branch compound, then give the name to the compound that we form. So from here 1, 2, counting from right, the branch compound formed on the second carbon. Counting from your left, the branch compound is formed on the 3rd carbon. So we can't name it by using 3, but can name it by using 2 because 2 is very close than 3. So we say that the name of this compound becomes 2 And the name of the branch compound is called methyl. 2-methyl. Then come and count the carbon of the longer chain. 1, 2, 3, 4. Or 1, 2, 3, 4. Or 1, 2. So this one, even this one's not part. So the longer chain is just 4. And the name becomes. So now, the longest hydrocarbon here is 4. The longest chain hydrocarbon is 4. So the name becomes butane. So we say 2-methyl butane. Okay. So let's try also reduce the number of carbons to 3. And try and then branch the other 2 carbons and see what we get. C here. And let's use the other 2 carbons here. Carbon there, another carbon there. So let's try and then link them. 1, 2. Let's link them. Okay, hydrogen can be there. Then hydrogen will be here. Hydrogen will be here. Okay. Hydrogen is here. Hydrogen is here. So let's count them and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 with 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So the same as the number of hydrogens for the pentane and then for the 2-methyl butane. So now, let's try and name this particular compound and see. Counting from the right to the left, the branch compounds are formed on the second carbon. From the left to the right, they are formed on the second carbon. Therefore, the name becomes 2. You write 2 first, and consider there are how many branch compounds? There are 2. 1 methyl here, another methyl also here. They are all formed on the second carbon. So say 2. And you bring comma because there are 2 branch compounds. You say 2, 2, and then when I write a number between a number, we use comma to separate them, and a number and a letter, we use hyphen. So 2, 2. How many branch compound do we have? We have 2. So we say dimethyl. The di means 2. So 2, 2 dimethyl, and then you count the carbon of the longer chain. 1, 2, 3, or 1, 2, 3, or 1, 2, 3, and then it becomes propane. So basically, this is how we name our compounds, and then how the names changes, the structure changes, but they all have the same molecular formula. Thank you.